notes on the top of page 22. Notes on the top of page 22. Talks about what does it mean to actually solve an equation. So solving the equation, in this case we solved 2x squared minus 12x minus 14 equals 0. It's an equation because it has an equal sign, something on the left, something on the right, is the same as finding the zeros or x-intercepts of the function f of x equals 2x squared minus 12x minus 14. So quite often we'll get a function like this and it will say, okay, find the x-intercepts or find the zeros. In order to do that, we take the function itself and we would set it equal to 0 and then solve for x. And that will give us our two x-intercepts, or they're also called our zeros. So the two solutions that we had in example 1, when we got x equals 7 or x equals negative 1, those are actually the two x-intercepts of the function f of x equals 2x squared minus 12x minus 14. Okay? However, not all quadratic functions have two intercepts. Not all quadratic functions have two intercepts. I should say two x-intercepts. Can you think of an example that wouldn't have an x-intercept? Remember, a quadratic function is a parabola. Opening up or down, fat or skinny. Can you think of an example where a parabola would not cross the x-axis? Some have, and we're going to do this. We're doing three little diagrams. Two x-intercepts, two x-ints. Some have one x-int, and some have no x-ints. And just a quick little diagram for each of those. Two x-intercepts is pretty straightforward. Doesn't matter how big or small or whatever or where it is, if it's to the left of 0 or to the right of 0, it's going to cross in two places. So when you factor it out, you will get two solutions. One x-intercept, however, means that the vertex is on the x-axis. This parabola is just going to touch in one spot and then go back down. Or it might open up, but either way the vertex is on the x-axis. This has one x-intercept. And the last option is no x-intercepts. That's simply if the parabola never crosses the x-axis. Okay? Today we're going to learn more about how we figure out if they do or don't cross the x-axis based on the equation itself and some math work that we do with it. Okay, so example 2. Connect the number of zeros to a graph. For each quadratic equation, graph the related function using graphing technology. You don't have to do that. I already put a picture of the graph there in your booklet. State the number of solutions of the original equation. So in this first one, how many solutions will there be? Remember, solutions is the same as zeros, which is the same as x-intercepts. How many are there? 2, right? There's one there, there's one there. This one has 2 solutions. Next one. 0. It never crosses the x-axis. 0 solutions. Last one. 1, right? It just touches. The vertex is on the x-axis, so it has 1 solution. Okay, that one's pretty straightforward. Example 3. Connect the number of zeros to the quadratic formula. And here's where we're going to start to see some of these connections. So we have our first one there is negative 2x squared plus 8x minus 5. And we're going to plug that into the quadratic equation. So we know our parameters. A is negative 2, B is positive 8, and C is negative 5. So we've got x equals negative b, which is negative 8, plus or minus square root of b squared, which is 8 squared, minus 4 times negative 2 times negative 5, all over 2 times negative 2. If we work this out, we end up with negative 8 plus or minus square root of 64 minus 40. So we know it's minus 40 because we've got 3 negative factors. So a negative times a negative is a positive times another negative is negative. 4 times 2 is 8. 8 times 5 is 40. All over negative 4. And then we can split this into 2 things and simplify our radicand here. We've got negative 8 plus the square root of 24 over negative 4. And we have negative 8 minus the square root of 24 over negative 4. And we can work both of these down. Is this radical in simplest forms? Or can we pull out a square number from there? So 24 can be represented as 4 times 6. 4 is a square number. Square root of 4 is 2. So this square root of 24 can be 2 radical 6 over negative 4. And same over here. And then this can be reduced a little bit further because both of these terms in the numerator, we can cancel out a little bit of this. We can divide each term here by 2. So we're going to end up with negative 4 plus the square root of 6 over negative 2. And in another step, what I can do too is multiply each term by negative 1. Or I could have, up here, I could have said instead of dividing by 2, I could divide each term by negative 2. And that would pull the negative sign out as well. So if that happened, we would flip each sign. In which case you'd have 4 minus the square root of 6 over 2. Over here I'll show it a little bit better. So instead of dividing out 2 from each term, we'll divide out negative 2. It's going to leave us with 4 plus radical 6 over 2. These are the exact solutions, and there are 2 solutions, and the connection that we want to make here is that once we got to this step, which I didn't actually really copy down nicely, the value under the radical is positive. So if the value under the radical is positive, the equation has two solutions. Example B gives us 8x squared minus 11x plus 5 equals 0. And again, we're going to note our parameters. We've got a equals 8, b is negative 11, c is 5, x equals negative b, which is positive 11, plus or minus the square root of b squared. I'm just going to go ahead and write 121. So negative 11 squared is 121, minus 4ac. So that's 4 times 5 is 20, times 8 is 160. All over 2 times a, which is 16. So now we've got 11 plus or minus the square root of negative 121 minus 60. I'm going to go with negative 39. All over 16. What do we notice about the number under the radical?
It's negative. So there's only one solution.
Since there is no such thing as the square root of a negative number, this equation has no solutions. Okay, so there's your trick. If you ever get a negative under the radical, no solutions. This equation, this function represented by this equation, will never cross the x-axis. Good to erase? The last one there is going to give us our third type of example. So you already know what's going to happen. In the end, it's going to have one solution. But we've got negative 4x squared plus 12x minus 9 equals 0. A is negative 4, B is 12, C is negative 9, x equals negative b, which is negative 12, plus or minus the square root of b squared. I'm just going to write 144 right away. That's 12 squared is 144, minus 4ac. Okay, 4 times, we'll just write it, negative 4, negative 9, all over 2a, 2 times negative 4. And we're rewriting it, negative 12 plus or minus. We're paying special attention to what happens to our value under the radical here. We've got 144. I'll rewrite that. Minus, because I have a negative times a negative times a negative. And 4 times 4 is 16, times 9 is 144. So what happens to that number in the radical? Becomes 0. You take the square root of 0. You can. It's just 0. And what that does, it turns this whole thing into 0. So now you have negative 12 plus 0 and negative 12 minus 0. Well, that's both just negative 12, right? So in this situation, if the value under the radical is 0, the equation has one solution. So in order to prove that, I can just kind of finish out this equation. Remember, negative 12 plus 0 and negative 12 minus 0 is the same thing. So you're just left with negative 12 over negative 8, which is positive 12 over 8. And then we can reduce that. It becomes 3 over 2. one solution. This brings us to a note on the discriminant. 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 This is b squared minus 4ac. Okay? That is the discriminant. Yep. Shouldn't be minus b though. Can help determine whether an equation has 0, 1, or 2 solutions. If b squared minus 4ac is greater than 0, then 2 solutions. If b squared minus 4ac is equal to 0, then 1 solution. If b squared minus 4ac is less than 0, if it's a negative number, then no solution. So in example 4, you're just asked to use the discriminant to determine the number of solutions. Okay, and we'll leave that little chart up there for us. But we've got in A, I'm just going to write the parameters. A is negative 2, B is positive 3, C is positive 8. And all we have to do is take the discriminant, b squared minus 4ac. So b squared is 3 squared minus 4 times a, which is negative 2, times c, which is 8. So all we're doing is taking b squared minus 4ac. Yeah? B squared right there.
Yeah, okay.
And we're deciding, is it this case, or this case? Well, we've got 9. This is a positive 8 times 8 is positive 64. We've got 9 plus 64. This is positive. How many solutions does it have? How many solutions if the discriminant is positive? 2 solutions. Therefore, 2 solutions. Okay, we're not asked to find out what the solutions are. We're just asked to find out if this thing is actually going to cross the x-axis and how many times is it going to cross the x-axis. Okay? In B, we've got A is 3, B is negative 5, C is 11. And we're looking at the discriminant. We're just looking at b squared minus 4ac. So it's going to be negative 5 squared, which is positive 25. And then minus 4 times 3 times 11. We got 25 minus 12 times 11, which is 133. Yep. Which is obviously going to be a negative number. How many solutions? Okay? So look up here if you're not sure. It's less than 0, no solutions. Because you can't take the square root of a negative number. Let's see if I can.
Last one is equal to 0.
Correct, way to go. So C, we've got A equals 1/4. We've got B equals negative 3. We've got C equals 9. And we're going to use the discriminant. So B squared is negative 3 squared, which is 9, minus 4 AC. And in order to fit it on my board here, you can kind of see 4 times 1/4 is just 1. 1 times 9 is 9. So we've got 9 minus 9. How many solutions? One solution. Thanks for sticking with it. Practice problems are found on page 49. Number 1, 3, 5, and 6.